All right,
Cheers.
yeah, recording. Go ahead.
Can I actually start? I have to go in a second, and I have something to say real quick.
All right, welcome everyone. Hi, Danny. Let's get a startup going.
Cool. I'm about to go to Berkeley to that conference.
Cool.
I'm going to be working on documentation of Vlad's Casper for our chain. Just that task is a little bit up in the air right now, but so I'm gonna be sifting through all sorts of stuff and might be knocking on somebody else's doors for some more info.
Cool. We're gonna be at the Berkeley thing ourselves, so we chat. Yeah, my plan is that by DevCon I'm gonna have documentation, code, like high level educational stuff, like all published.
Oh, sweet.
Or slash maybe I'll hit the button at DevCon. We'll see.
Well, if you need some assistance with that,
I actually totally do. So yeah, maybe working together on that makes sense.
okay. Well, I'll ping you outside the channel, but that's all.
I'll see you at Berkeley today.
Sweet. I'll reach out.
Was that what you had to say?
That's all I got right now. Yeah.
Cool. Carl?
Sure. So not too many updates on the development front. The biggest kind of update is with the Casper Finality gadget. It's moving from 2 message types to 1 message type. So going from prepare commits to votes. And the actual change is kind of like, maybe one way to understand the move is prepare and commits were kind of a enforced kind of successive voting, like 2/3 voting, and now we're not making that kind of we can reduce the epoch length from like 100 to 50, and just to make it so that you have to get 2 successive epochs justified. So it's kind of like the same thing in some ways, except not as except just like fewer arbitrary distinctions between the kind of like prepares and commits. There's a post that Vitalik made that kind of goes into a little bit more detail. But yeah, so I mean that's probably the biggest update.
But it takes 2 rounds to get finality.
Yeah, still takes 2 rounds to get finality. Yeah, 2 rounds to get finality.
Okay, so it's like the
epoch.
prepares on the prepares on the next checkpoint are like committing the previous checkpoint.
The prepares on the next checkpoint. Yeah, exactly, kind of.
Even if there's like a missing one.
Yeah.
Right. The previous one that got 2/3.
Okay.
No, it has.
Or it has to be referenced.
Yeah.
Do you want to tell us about that? That sounds key.
Yeah. Okay. So I mean, it has to be successive, but I should not tell you about it because
maybe we need Vitalik here.
We need Vitalik here because, yeah, I won't go into my.
Yeah, but Danny posted a link there.
Great.
With like has like the sharing of the thing.
Yeah, I was gonna. I the first time I read it, I also thought that the the finalization didn't have to be successive. I like tried looking into it yesterday, and the best I can figure out, it's like hidden somewhere in the safety proof is the reason why.
Yeah, it does say direct child.
Yeah, I asked about it even because I thought that would mean that we would kind of lose like the interwoven consensus thing where like we can keep building blocks and then eventually finalize them. But then I realized that the one good thing is that justified blocks don't have to be next to each other. Like they can skip kind of multiple epochs, but the finalized blocks do have to be successive for some reason.
Interesting.
Yeah, I mean it's pretty. I'm quite sure that you can just like come up with an example where you can cause a chain reversion if they're not successive. But yeah, it's it's maybe not intuitive why they have to be exactly successful.
Okay, we'll have to wrap around to this next week. Hopefully someone, put the pin in and remembers.
Yeah.
How big of a code change is that on the Viper contract?
Oh yeah, so this is actually going to reduce the amount of code very likely in the Viper contract. It is
A major change, yeah?
but it is a major change.
Got it.
Cool. Yeah. I mean, this is why I love my correct by construction protocols, because the safety proof is so simple. You don't have to worry about this type of thing. Like, what are rounds? Like, there's no rounds. It's really. I really love the adversary abstraction and the
You
estimate.
just have to make your adversary better and better.
No, not. I mean, so it may. I mean. Not quite. So basically, like, the ideal adversary implements an ideal safety oracle, and any safety oracle that's consistent with it is kind of legitimate. And somehow the adversary abstraction provides a way to find different safety oracles. It's not that the adversary gets better. I mean, making a better adversary is one way to find other oracles.
Right.
But in terms of my research, there's kind of two things that kind of happened last week. Not that much. I was in Moscow all week. It was a really interesting time. May have found some people who may want to implement Casper, which is kind of exciting in some way, because they're going to do it to like a kind of high engineering performance kind of standard if they do it. But basically, the two kind of things is, one of them is I realized the trick that I gave last stand up for adding validators in without by using a block that they create rather than in the previous block. While it does mean that like while it works theoretically and like inherits all the properties of the proof, it's kind of impractical because it means that like you need to calculate safety with respect to anyone who could opt in. And so you have this it's rather like the number of like it's like way harder to achieve safety in some way because you need way more of the stake to participate to have safety, because like the new stake could come in and fork the chain. And so like, even though like it's technically possible to be safe, the safety oracle will in practice be always returning not safe because like there won't be that level of participation. So, while it's a cool idea from the point of view of rebooting the chain if people go offline and like always having liveness, in terms of it being practical for safety, I think I'm almost entirely ready to like rule it out and to basically say that like it's kind of fundamental that if all validators crash forever, we're never going to get another block without a UASF or hard fork.
Yeah.
So that's one thing. The other thing is I was having some discussions with Vitalik and basically about kind of efficiently implementing the justification structure and making sure that like the minimum amount of stuff gets propagated across the network. And that was kind of interesting. Not that many takeaways other than like, okay, like basically like, there's some minimum set of previous things that you can point to give that will kind of have in their dependency all the latest messages you've seen. So you need to really somehow from looking at your block, someone needs to be able to figure out what the latest messages you've seen are, right? And there's like some smallest number of previous messages that you could point to show that, right?
Yeah.
And like that's kind of your obligation. And if we want to add this kind of redundancy freeness rule, or a rule that basically says that blocks are only valid if they have a minimum justification, which would reduce network overhead a lot, which was our kind of concern during that conversation. So that's like the little update I have.
Sorry, can I ask a question about that?
Oh yeah, go ahead.
So you say like they point to a minimum number of blocks in their justification. Are you saying like they don't necessarily have to show you all of the blocks in their justification for you to consider them?
They don't necessarily have to have like a map of all the latest messages they've seen. They just need to have enough that if you were to download all the dependencies, you would find them.
Cool. Okay, cool.
Another way to put it is if you were to just watch bets arrive at your door, kind of from the point of view of like a validator who has like access to like, complete protocol states. Every additional justification really only adds to that model validator's view the new things they've seen. So that basically, we have the minimum amount of stuff on the network to update our model validators.
Yeah, I get you. Okay, cool.
I'm less sure about that than I was about the previous stuff I said though. So, take that one with a grain of salt.
Will do.
You have any updates, Nate?
Yeah. So I guess actually I'll switch the order of my updates because my first thing kind of relates very closely to what you just talked about. So the first part of the update relates to the the minimum amount of message propagation stuff. So kind of I have a branch where I've kind of been reworking the network and reworking the validators to kind of make it so when they pass a message, what they include in their justification is just the hash and also the sender in the justification. And when you receive messages, you kind of don't consider them finalized, you don't consider their weight to contribute to the fork choice until you have all of the messages that kind of justify their thing. So kind of this thing you've been talking about.
Super cool. Great. So there's like a staging area. What do you call it?
Yeah, I call it pending blocks, but it's, the names are in a state of flux. They kind of suck right now.
I like staging better than pending, but
yeah, me too. But kind of, and then I set up a like a DAG to some degree, where I have like blocks kind of subscribe to other block hashes. And then once we kind of receive those blocks, then they kind of resolve. And then if for example, like if we have block B waiting on block A, and kind of we get block A and that resolves block B, then all the future blocks that are waiting on block B also hypothetically resolve.
Super cool.
Yeah. So anyways, is great. I think it's mostly working, with the exception of none of our message prop orders / strategies as of now kind of work with it at all. So kind of in this, it's kind of like they build on top of each other. Maybe one validator.
That'll be refactored eventually. It's fine.
Yeah, exactly. But kind of the one cool thing is like with full message propagation. So like every round, everyone gets every other message. Kind of things work exactly the same, and we still kind of, just have one block from each validator. We still have the same number of blocks, but it's kind of less crazy. You're not passing everything in your justification.
Yeah, no, that's really cool.
So it's cool.
Yeah, great work. Yeah, nice one.
Yeah. I might message you more about that offline because I have some
cool
lingering thoughts and stuff. But okay, yeah. The second part of my update.
You muted yourself.
Sorry. The second part of my update. I'm going to share a video real quick if that's cool.
Yeah, totally.
Yay!
Yeah, it's always fun part.
Go Nate.
Cool. Can you see this?
Yep.
Cool.
Oh my god.
This is the correct by construction Casper testing language.
That's awesome. I'm so excited.
Yeah, this is awesome.
This is so great.
So as you can tell, wait, sorry, I'm getting a little feedback. Is someone unmuted? Sorry. Okay, cheers. It's gone. All right. Yeah. So it's very closely modeled after the Casper testing language, with some differences. Kind of, we need finer grained control over blocks because they're kind of like the main unit of everything, as compared to prepares and commits. And so kind of we need more control over the individual blocks, and for that reason we kind of give the blocks names themselves. So why don't I run this real quick, and then we can kind of we can walk through one of them. So let's run this real quick. So you can see we can put it in like pretty interesting situations. Like here's a network fork, and we have some other random guy on the side, and this is like a test case of like, majority network fork. Kind of these guys can still recognize safety. Here's maybe a more interesting one where we have an extended network fork, and we kind of make sure that they don't, find safety at any point during this network fork. And then we kind of show everybody everything, and then we kind of say, oh, well, now who has safety, and we kind of make sure that that's the right fork. And then, yeah, I guess this is very similar. I don't know what that is. Yeah, so kind of, it's pretty fun. Would it be helpful for me to like walk through a single test case just to kind of talk about what it does?
Can you walk through the language specification?
Yeah, for sure.
Same activity, but yeah, I definitely need to see. I want to see like, how it works.
Yeah, so I think that probably the best way to do that is just a real quick example. So R is a report, so that's kind of print the current state of the current global state to the screen. That's just display everything. B-1-A, this says make a block validator 1. So it says validator 1 make a block and name it A, right? This says send validator 0 block A. So this is make a block and who is making it, and this is send a block and this is who's receiving it. And this is kind of why we need names for our blocks.
Here's a question. After they receive it, do they immediately make a new block with that one in the justification, or do you have to make a new? Okay, great.
Yeah, no. No one does. Pretty much no one does anything unless we kind of tell them to do it. They'll take it and they'll like process it, if that makes sense. Like they'll add it to their justification in their own view, but they won't make a new block or anything. So they pretty much essentially haven't committed to this.
Yeah, that makes sense. Although it's not the only way you could have done it, but it makes sense. Go on.
Yep. Let's see what else. So yeah, so we're making more blocks, sending more blocks. Then up here we have H. This is very similar. I stole this from Casper, hybrid Casper. This kind of checks the head. So this says like the current fork choice of validator 1 should be block 4. And this kind of says that check safety on for validator 1, check safety on block 0.
And if it fails, it throws?
No. It does not. Currently, it does not throw on safety checks. On unsafe checks, it does throw if it detects that safety when it shouldn't. But it does not. It does not throw if it checks for safety and it doesn't get it. And that's because it might be some degree of a lower bound. And I kind of want to make it agnostic to the safety oracle.
Maybe you shouldn't, because we want to test safety oracles separately at some point. But for now, I guess it's fine.
Okay. Yeah, I mean, I can make it throw. It's not a super big change. But cool. The one reason why it might be good to kind of not throw is kind of maybe just as a very rudimentary way of comparing safety oracles to each other, we can kind of say oh, this check safety 50 times and got it 30 of them compared to this check safety 50 times and got it 20 of them. Something.
Yeah, but you can basically have like instead of S, just like S, we can have like a bunch of safety oracles.
Yeah, sure. Yeah. Okay, I get you. Yeah.
Bye, Danny.
Bye, Danny.
Later.
So yeah.
Yeah. So go on.
Yeah. And I guess that's most of the specification. There's one more kind of message thing, which is there's this one U, which is check unsafe. And that this kind of should never fail. Like if we don't have safety, we should never think we have safety, right? And so this is like, this is in the case of a network split, where neither side has a majority. They should never detect safety. And then the one more one is like RR, which is just like round robin, and it pretty much just like pick a validator, start with them, make a bunch of blocks. It's the two times the number of or one times the number of validators, but we do it twice, and then we always.
Oh, cool. So it goes all the way around. It's like
yeah.
Well, cool. Oh, this is really cool. Really cool, Nate.
Thanks.
Yeah.
The only kind of thought I had is one of the things that I was kind of struggling for a while in terms of my adversary model about whether to like send bets and make bets as a separate thing, and then or blocks or messages or whatever. So now I have this this kind of notion that a move in the protocol is adding a message to the protocol, and an elementary move is one where it's basically a new latest message with one new thing in the justification. And so, and basically that one new thing is what you would propagate. And so when you say like, okay, so I would have like the way that I've done is like have one operation, which creates a new validator, a new message for validator I as the result of showing block A.
Yeah, I've noticed that before, specifically that every time a validator receives a block, kind of they generate one.
Yeah, so I ended up doing that because it led to there being only one operation type. instead of having one for send and one for make a block.
Interesting. I mean, isn't this model kind of just more flexible?
Yeah,
in the sense that, like, if we want, we can totally do exactly what you're saying.
Yeah, no, I think it's better from the point of view of like it's closer to what's actually going to be implemented. But when I was first struggling with it, I was just trying to like write down some equations, and having like one fewer operation really was nice.
Sure. Yeah, makes sense.
Oh, yeah, but I think in terms of say validator strategies, like you would imagine that you may not want to produce a block every time you receive one.
Yeah. Mm-hmm.
Hopefully, I guess. Maybe, hopefully. I don't know, but getcha. Cool. So anyway, I'm gonna post at some point. I gotta clean up the repo a fair bit, but I'm gonna post the testing language and some kind of basic tests, like sanity checks and stuff. I'll post that, and I don't know if you guys think of any interesting, situations to put it in. Let me know.
Cool.
That sounds great. I love the network partition one. I think one thing that I would love to test is orphan rates in a blockchain, where basically you're trying to make a blockchain, and like there's some rate of orphanage. I think Vitalik's made models for this before. But that would be something that would be definitely cool to see, because what I want to see is this trade-off between orphan rates and finality times. So basically, higher orphan rates should need more finality times if we're still building on the blockchain. Some shorter time to finality.
Sure.
Or lower overhead, higher overhead.
Mm-hmm.
So I'd love to see I would love to see a couple of things. I guess I would like to see orphan rates, and also proportion of marginal cost of block finality, right? So basically, how many finalized blocks are there divided by the number of blocks?
In specific context, or like just in general, if we run
different orphan rates.
I see.
I want to have plot out orphan rates versus
percentage of blocks kind of get finalized.
Exactly. Yeah.
Oh, interesting. Cool. Yeah, the network partition one I thought was really cool, kind of because I don't know, the example you always give is like, in the case of a network partition, like, I mean, obviously you can't maintain your safety and, but, cap, whatever, et cetera. But kind of the cool point that you made is like, they'll both know that they're not safe, but like to actually kind of see them doing that is like, I don't know, it made me really excited. So
yeah, it's totally cool, right? That's one of the things I've long been in favor about proof stake, is you can tell how safe you are in the context of partition.
Yeah, that's fun.
You have to kind of like guess the blocks are coming slower.
Yep.
And it takes a few confirmations.
Yeah. So cool.
Yeah.
Cool. That's it for me.
Sweet. Well, this has been a pretty cool stand-up. I don't think I have anything really else to share.
All right, great. I guess I'll see you guys. Have fun at the Berkeley conference.
Yeah.
Yeah, thank you.
Have fun, with your midterms.
Dude, you have no idea, man.
See you guys.
All right, see you.
Peace.